Hi, my name is Jaehyun Cho and I'm going to present Advanced Structural Mechanics Week 6 project. This is the 3D body I selected. I selected both and divided into 4 parts. First, I computed tangent vectors. For part 1, it is parameterized as LBH, so the tangent vectors are like this. And for part 2, is parameterized as L b times 1 minus small l minus larger over large L and H. So tangent vectors are like this. For part 3, L goes to minus L, so the tangent vectors go to minus 1. For part 4, it is parameterized as R cosine theta, R times sine theta, H. So tangent vectors are like this. So this is the code that I put it into MATLAB for the tangent vectors. And then I define the deformation map. In my case, I selected vector field. It's like this from previous week. So I defined the deformation map like this. It's G1 plus 10 times sine G3 over H1 plus H2 times pi over 2, and G2 minus 10 times sine G3 H1 plus H2 times pi over 2, and 0.8 G3 minus G1 over 4L times G3 over H1 plus H2 plus G2 over 2B times G3 over H1 plus H2. So this is the code I put it into MATLAB for the deformation map. And then I computed the deformation gradient. The results are like this. It's 1, 0, and like this, 0, 1, like this, and like this. So I put it the deformation gradient into MATLAB like this. So this is the results of my MATLAB. Part 1 is consisted with 8 curves, part 2 is consisted with 7 curves, and part 3 is consisted of 7 curves, and part 4 is consisted of 2 curves. The one is along with the height. So I'm going to check this curve. For undeformed curve is parameterized as 0, 0s, and its length is 50. So the deformation map goes to like this, and so parameterization of deformed curves is 10 sine s over h1 plus h2 times pi over 2 minus 10 sine s1 h1 plus h2 times pi over 2 and 0.s. So the tangent vector to deformed curves can be calculated like this, and the deformed length is 42.774 when I calculate this, and it's same with the MATLAB. Thank you.